Hi everyone, my name is Thomas Kim. Today is May 27th, 2019. This is my 21st episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn simple trick to boost performance of C++ standard library. In episode 20, we learned about copy elision and named return value optimization. This technique is very simple but very effective way to optimize your C++ code. In this episode, we will learn about STD, addressof function, and emplace spec, and emplace front. How to use these functions properly. If you have learned C++ 98 standard, you are very likely accustomed to pushback or push front member functions. Though they are not yet deprecated, they do not provide performance for your modern C++ programming. I also use pushback or push front from time to time because these are my old habits. As they say, old habits die hard. Now is the time you give up on these old schools and adopt new functions offered by new C++ 11 standard. If you are new audience to my YouTube channel, please visit extensiontalkplayfun.com website and click this link to download complete source code, and click this link system environment variables for Visual C++, GNU G++, and Clang. If you haven't watched this video and haven't made proper system environment variable settings for Visual C++, GNU G++, and Clang++, you may not be able to follow this episode. Please watch this video and make proper system environment variable settings. Now click Show in folder. If you unzip this file, you can find CPP extension folder. In this folder, you can find the tutorial folder. Please copy this folder and paste it to your working directory and start Visual Studio Code and open CPP extension folder. If you open this CPP extension folder, you can find the tutorials folder. Please click this folder, click this button, O21 emplace.cpp. I will close welcome screen, Ctrl V, include talk play fun, output HPP. I create a class, dangerous practice, private int mptr null ptr public. I will copy this int ptr null ptr, mptr new int. I will make it size t, size it is 1. Default value is not 0. Size we dynamically allocate. This is dangerous practice. I will explain why this is dangerous practice in some future sessions. Anyway, let's keep going. Then here I say at global scope talk play fun access stream auto and talk play fun and here stream default constructor called and I will create a member function here void release if mptr delete mptr this mptr null ptr. Here I create copy constructor dangerous practice right hand side it should be constant. Please note that this is copy constructor ptr. We have to dynamically allocate new int right hand side. We need a member function here size t size should be 0. Okay, then size we dynamically allocate it. Now we have to copy. We can use std memcpy it should be included in include cstdlib. Here the first is target, this mptr. The second is source size right hand side size. I will change the order. Here we have to change the order. Order doesn't matter. Okay, I have changed the order like this. And I don't think we need to initialize it here. Also, we don't need this. Size. Okay, and this is wrong. Size is greater than 0. Otherwise, null ptr. Then I will modify the order, cut, paste. Also here, size greater than 0. Otherwise, null ptr. So I modified like this. Then we have to copy. This is source, this is target, source is right hand side, mptr, msize. Of course, if msize greater than 0. Okay, this is the proper way. This is copy constructor. Now we are making copy operator. Dangerous practice, constant dangerous practice, right hand side. Sorry, operator. This is copy operator. If this is not equal to std, address of right hand side, then we can do this. We have to release our memory because this is copy constructor. First, we release our current memory. This msize, right hand side, msize. If this msize greater than 0, then we allocate this mptr new int this msize. We allocated the memory, then we copied the memory. Now at this point, return this. Now I will explain this part. Okay, I promised to explain about std address of in this episode. Now we are creating an operator, integer pointer operator, address of operator. Okay, return this mptr. Okay, so we defined operator, address of operator. It is wrong. This right hand side this code is wrong because address of operator is defined for class dangerous practice. Okay, so we cannot use the following code any longer. That's why this address of operator function is important. Now I explained address of. Now let's create move constructor. Dangerous practice. Dangerous practice. This is move constructor, right hand side. Now in this case, watch it carefully. This msize, right hand side, msize. This mptr right hand side MPTR. We are stealing the member MPTR's memory. After this, right hand side, we release right hand side. So we release right hand side. We should not do this, okay? I have to fix. Copy. I made a mistake here. This is release. This is free memory. So I have to fix like this. Copy this. Here we have to fix like this, free memory. Okay. Now here it is release. So in this case it does not release memory. It does not release memory. It does not delete memory. It just modifies pointer to null. In this case it frees memory like this. Okay. So please understand this concept. In case of copy constructor, we have to allocate memory for our constructor, and we have to copy memory from MPTR right hand side. We have to copy the memory. In case of assignment, this is copy assignment. We pre-existing memory. We have to free our existing memory. Then we allocate new memory. We have to allocate new memory. Then we copy the contents. Okay? So here we can have another chance. Here we can optimize more like this. If this M size equal to this right hand side M size, we do not need to allocate. In this case, we do not need to allocate. Else, in this case, we have to allocate. Okay? Now I will copy this. In this case, we do not need to allocate memory. We can simply copy. We do not release our memory. This free memory, we do not need to reallocate memory, and also we do not need to free memory. We just simply copy the contents if the size of left hand side, right hand side are equal. Otherwise we have to free existing memory and reallocate. We have to reallocate new memory. Then we copy. So this is the optimized way of copy constructor. This is move constructor. I will modify like this. Cut, paste, like this, and mptr right hand side mptr, we can say just release. I fixed like this. So in this case, release case, we don't need this. We can simply do like this. This is this M size. We have to fix like this. This M size. And this is move constructor. When we do memory copy, this is byte size. Okay, we have to fix like this. Size of int. Okay, we need this because this copy is byte size. And here we also need to do this size of int. And this should also be fixed. Size of int. Okay. Now let's make move assignment. I will copy this and paste it here. It should be move assignment like this. In case of move assignment, we have to release our existing memory, free memory. Delete existing memory. This M size, right hand side M size. This M ptr, right hand side M ptr. Okay, but before we do this, we need this std address of right hand side. Then we have to fix like this. Now we delete this part. Note, in this case we do not reallocate memory, so we can say no except. It does not throw exception because we do not reallocate memory. Okay? And in this case, we also do not reallocate memory. So it can be no except because we do not allocate memory. And don't forget this release. And here we have to release right hand side release. Important. Invalidate right hand side after move assignment. Also here important. Invalidate right hand side. Okay, instead of release I will say invalidate. Invalidate. Okay, I will copy this. I will modify like this. Okay, this step is very important. Since after move operation, right hand side is invalid, so we should not access we should not access to right hand side after move operation. Okay, also here after move right hand side invalid, so we should not access to right hand side after move operation. Understanding this part is very important. Okay, now let's check. We need to create this structure. Copy this, paste. It should be this pre-memory. Okay, so pre-memory should safeguard. We can say this M size is not 0 or MPTR is not null PTR. Okay, we actually don't need this part, or we don't need this part, but I made it to make it clear. Now let's double check. When we copy memory, M size should be greater than 0, and here also we have to double check. If M size greater than 0, we have to fix like this, and this is done properly. Now if dynamic allocation fails, it throws. We dynamically allocate memory here. If dynamic allocation fails, this constructor throws std fed alloc exception. Okay, also here in copy constructor, if dynamic allocation fails, it throws exception. Also in copy assignment, it also dynamically allocates. In this case, it can throw. If allocation fails, it can throw std fed alloc exception. Now we define one more operator here. Int reference operator index operator size t index, return this mptr index. Okay, we also need one more. Copy, paste. It should be constant, and it should be constant, and it does not throw exception, so we can say no except. No, it can throw exception. This is dangerous practice. It can throw exception. Okay, if it fails, it probably crash. So I will just do this, or I can make another one. Anti-reference at size t index. If index is less than this m size and this mptr is not null ptr. Okay, then we can throw return this mptr index. Otherwise, else talk play fun, throw debug exception, index out of range. I copy once again, constant, constant. Okay, I will copy this and rename it. I will rename it. It has no rename. I say dynamic array. I will replace all. Okay. I will create two more member function. We need to access this size of the array. So here size t size constant, return this m size, and I will create another function void resize. It should be size t count. If count is less than 1, we throw talk, play, fun, throw exception. Count should be greater than 0. Else if count equals this m size, then we can simply return. Else we dynamically allocate. We first free memory, pre-existing memory. Now here try this m size count. This mptr new int, this m size catch. We will throw talk, play, fun, throw debugging exception, dynamic allocation failed. So we resize our memory, and also this is not good practice. If it throws exception, it throws failed allocate. In such case, we cannot have information. So I will modify like this. Try catch. I will cut this part, cut, paste it here. I modified like this. At this point, talk, play, fun, throw debug exception, dynamic allocation failed. It gives us, it reports details about allocation failure. Also, we modify this part. Cut, try, catch. We can copy this part. And also we can copy this part. It should be this m size, this m size. We have to fix like this, and whenever we dynamically allocate, here also try catch. I will copy this part, copy, paste. Now I will make a friend function like this. Friend std o stream operator std o stream os constant dynamic array da. If da size less than 1 means it is 0, os we create simply empty string, else os for size t I equals 0, I less than, I will say size here, size t count da size, okay, -1. Here size plus I os I os da, sorry, da like this, size. Please note that we minus the 1 here, so this is valid operation. Now here we return OS. Now I will copy a few strings for message. This is constructor cut. I will paste it here. Default constructor called, and I will paste it here. This is copy constructor, and I will paste it here. This is copy assignment. And I will paste once again. This is move constructor, and I will paste it here. This is move assignment operator. Finally, template, type name, element type, and I will change all occurrence of int to element type to make it template class. Replace all. So now it becomes template class. Void examples for dynamic array. Dynamic array int a, we allocate 10 elements for size ti equals 0, I less than a size plus I a I, we initialize int I stream a and l int main. We call this function copy paste. Start your command prompt. You should be in tutorial folder, CPP extension tutorial folder. The file name is 021 emplace CPP. dir 021 cl ehsc std C++17 021 emplace cpp fe aexe. Wow, it built a. Wow, I missed one. Copy this here. Destructor called. I originally planned how to use emplace back, emplace back, emplace front. I will just use emplace back or emplace front. Now here I will create a function void. Do not do this. Okay, don't do this. std vector dynamic array int. Please note that we are creating array to array. Okay, I say jagged array. Don't do this. Don't do this. I will explain why. For size ti equals 0, I less than jagged array size plus I jagged array I we have to provide a dynamic array like this, and we put I plus 1. Okay, it should be at least one more than, because it starts with 0, the array size, this is array size, should be greater than 0. So we have to plus 1. Okay? Don't do this. I will explain why. Instead of 10, I would say 2. Okay? Now I copy this function, copy, paste here, CLS, hit enter. CLS, say, let's see how many times default constructor is called. How many times constructor is called. So we allocate 2 elements of vector. Default constructor is called. Default constructor is called. Okay? Twice, 3 times, then one move constructor and one move constructor. So default constructor is called 4 times. 1, 2, 3, 4. Default constructor is called 2 times and move constructor is called twice. I will explain here. I will put stream. At this point, default constructor of dynamic array is called, I will modify it, size t count. Okay, I modified like this. I put it here, count times. Okay, at this point, stream, in the for loop, default constructor of dynamic array is called count times, and move constructor is called count times. Stream. So destructor is called total count plus count for at this point, and here at this point. Times. Now let's try once again. CLS. So at this point, default constructor of dynamic array is called 2 times because count times. Okay, here it dynamically allocates internal memory, and at this point after the loop, in the for loop, default constructor of dynamic array is called 2 times, once and twice, and move constructor is called 2 times, once and twice. So destructor is called total 4 times. Okay, destructor is called once, twice, 3 times, 4 times. This is very inefficient. Please don't do this. void it still is not perfect. Now in this case, size t count is still 2. Don't do this, okay? Don't do this. Don't allocate memory here. Instead, checked array reserve count. Do like this, okay? Then I will copy this, paste, then here emplace back. It is still not perfect, okay? Now let's see how this function works. This is better, but not perfect. Okay, I will copy this and paste it here. I will disable it for the time being. We build once again. CLS. Why it does not show any message? Sorry, we have to fix like this. Copy. Paste like this. Or we can say, instead of size, we can use capacity. Capacity. Okay? We can do it like this. Let's try once again. CLS. Okay, this is much better, not perfect. Now let's count. Default constructor is called once. Default constructor is called twice. And move constructor is called once. And move constructor is called twice. So it is created 4 times. We removed the number of default constructor, but we still created 4 elements. 4 times. Destructor is called 4 times because of this part. Okay, this part is causing the problem. Now, this is perfect way. I will copy this. Please use this method. Okay? Instead of doing this, just change like this. Okay? Note that the constructor of dynamic array, in this case, this constructor takes size. Okay? So the constructor of dynamic array takes size t. So we can pass this size t element to here. Now std vector creates dynamic array internally. So no move, only count times of default constructor of dynamic array is called. Now copy this, paste like this. This is a perfect way. You should always use this method. Okay? Now let's build. CLS A. See, default constructor is called twice. Destructor called twice because we allocated two elements. Two jagged array is created. We have to use this method. Now I will make it more interesting. I will make it more interesting like this. Now we allocated memory, then we can initialize. I will change it into 10. Then for size t, we allocated int, so we will use int. Int j 0 j less than jagged array I, or we can say just back, and size, I will say size t. Then plus j, we can initialize like this. Jagged array back j int j. Okay, then we can display like this. For auto da jagged array, we can use reference like this. Stream da and there. Okay, now let's learn. CLS. Wow, we are creating jagged array. Please note that we created only 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We never created redundant temporary dynamic array. We never created temporary dynamic array in this function. I hope why you should use this method instead of allocating size here, then create and copy again. This is very bad practice. And this is still not perfect because we still create unnecessary temporary here. Instead, we provide parameters, arguments. I plus 1 is argument for dynamic array. So we always have to use this method. Now let me wrap up this episode. I always upload complete source code in this website, and by clicking this link you can download complete source code. Whatever you do with your C++ language, if you are a student at college or even at high school, never neglect studying mathematics. Mathematics combined with C++ language can bring you anything you want. If you want money or want to be rich, your math with C++ will surely bring it to you. If you want fame, it will bring it to your door. Dynamic array is the first step for any serious mathematical modeling. Once you completely understand and implement dynamic array all by yourself, implementing two-dimensional or three or more multi-dimensional array or matrix is just a piece of cake, which enables you to easily deal with linear algebra. I hope you enjoyed this episode.